All right, so the types of problems we're going to factor today look like this. They're quadratic expressions. X squared plus bx plus c. Okay? X squared plus bx plus c. What does that mean? The b and the c are constants. They're coefficients. So for example, okay, if I have x squared plus 5x plus 6, okay, that's the type of expression we're going to factor today. And factoring means we're going to come up with two things that when you FOIL them gives you back x squared plus 5x plus 6. Okay? The form in which we factor into is going to look like this. Okay? X plus something or x minus something. Okay? Now, what is important is this. We have to come up with these numbers m and n. Okay? And m plus n equals b. M times n equals c. What that means is for each problem, I'm going to come up with two numbers that when I add them together gives me b, and when I multiply them together, it gives me c. Okay? So let's do one. For this, we need to know about factors. So take a look at this one. This is, everybody's favorite example because it's so easy to do. X squared plus 5x plus 6. What you do is you write it as this. And here I'm going to get x, y. What does x times x equal to? X squared. That's the first term, x squared. Now, I need two numbers that when I multiply them, I get 6. When I add them, I get 5. What do you think? 3 and 2. So I do plus 3 plus 2. Okay? So it adds to this. It multiplies to this. So how would you check, right? Let's check. Let's do FOIL. Okay? The first terms give me what? X squared. Outer terms, 2x. Inner terms, 3x. Last terms, 6. X squared plus 5x plus 6, yes. Okay? That's how it works. Okay. So, let's do this one. X squared plus 6x plus 8. Okay? So, the way in which we do it, okay, there has to be a system. You take this number and you want to write down the factors of 8 that add to 6. So for example, what are the factors of 8? 1 and 8, 2 and 4. Which one of those pairs adds to 6? The second one, 2 and 4. Okay, so that's the one I'm going to use. So I say x plus 2, x plus 4. Okay? Okay. So here we go. Take a look at this one. I have x and x because that multiplies to x squared. So now I need factors of 4. Well, that could be 1 and 4, 2 and 2. Okay? Which one adds up to 5? This one. So because it's positive 1 and positive 4, I do plus 1 plus 4. Okay. Now, the next one, there's a problem. Okay? The next one, there's a problem. What's the problem for the next one? There is a negative. Yeah? So now I need to come up with those. So here we go. So here I'm going to do A. So how do I get negative 15, right? It's either negative 3 and 5 or 3 and negative 5, right? Or 1 and 15. Now is the 1, now what do they need to add up to? The 2. So now the factors of 15 are also 1 and 15, but are those going to add up to 2? No, so I don't bother with them, right? So now which one of these adds up to 2? I want this one, right, to add up to positive 2. Okay? So now look, it's going to be minus 3 plus 5. Okay? Now, the next one, I don't like it. Why don't I like the next one? They're out of order, right? It's not in standard form. Remember what it meant to put something in standard form? You write it with the biggest exponent first and then decreasing exponent. So let's put it in decreasing exponent. Let me tell you something. Even at my age, okay, me, Mrs. Malikian, with all the math I know, if I were to factor that one, first I would write it in the right order. Okay, it's just so much easier for me to think that way. Okay, so now I need factors of 9. What are factors of 9? 3 and 3 are factors of 9. Are those going to add to 10? No. How about 1 and 9? Yeah, that adds to 10. T plus 1, T plus 9. Okay? What have we noticed? Every single one, except for this one, yeah, had plus plus. Look at this one. Look at this one that we did. It's positive x squared, positive 6x, positive 8. This one, positive, positive, positive. C had a negative, but D is positive, positive, positive. So look at all the ones that have all positives. This one, this one, this one. Do you see how all the factors are plus, 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 right? X plus 2, X plus 4, X plus 1, X plus 4. Do you see that? So if the problem itself is plus, plus, then this will always be plus, plus. Because where is the negative going to come from? The place where you have a little bit of a play is if you have one of the terms as a negative or two of the terms as a negative. Okay? So let's take a look at this one. I need two numbers, right? So here, x. I need two numbers that multiply to 16, but add to negative 10. So you're like, oh, 2 and 8 multiplies to 16, but does that add to negative 8? No. So then what? Negative 2 and negative 8, now that adds to negative 10 and multiplies to positive 16. So do you see why now it's even more important that we know how to multiply and add and everything with the negatives, right? So look at this one. In the first case, oh, why isn't this showing up? In the first case, this adds to 10. This adds to negative 10. That's the one that I want. Okay, right? So do you see this? So I take the one that adds to negative 10. So now it's going to be minus 2 minus 8. Now what if somebody wrote x minus 8, x minus 2? Also works. Okay, both of them are okay. All right? Okay, so this one. I want you guys to do F and G on your own right now. All right, on your marks, get set, go. Minus 4. Okay, so I need positive 28, but they have to add up to a negative number. So now, what are the factors of 28? Well, 4 and 7 are factors, but then those add to positive 11, which I don't want. So negative 4 and negative 7, that also multiplies to positive 28, but now it adds to negative 11. So that's the one I want. Okay? So this is going to be x minus 4, x minus 7. Okay? Okay. Take a look at this one. I need two numbers to multiply to negative 18. The factors of 18 are like 2 and 9, 6 and 3. Okay? So suppose I do 6 and 3. Right? Does that multiply to negative 18? No. How about negative 6 and 3? Yeah, and then that adds to negative 3, which also is not something I want. How about 6 and negative 3? Yes, that adds to positive 3. That's what I want. So then it's going to be x plus 6, x minus 3. Okay? Another way that people arrange this is the following. They do an x, okay? And then the negative 18 goes here. Let's do a wider x. The negative 18 goes here. The 3 goes there, right? The positive 3. And so now, again, I just want two numbers that multiply to the top, add to the bottom. So it'll be, 6 and negative 3. It's the same sort of thing, but arranged differently. So you can use whichever one you want, okay? So these two, they multiply to negative 18. They add to 3. 6 plus negative 3 is 3.
Oh, I see.
Okay, so look at this one. Here. Okay, I need numbers that multiply to 20. Let's do 2 and 10. Oh, but I need negative 20, right? So let's do negative 2 and 10. What does that add to? That's positive 8. Okay, that's not even a thing. What if I do 2 and negative 10? That's negative. I'm not even on the right track with this, right? So now I go, okay, what are the other factors? 5 and 4, okay, so 5 and 4. Let's see. Let's do negative 5 and positive 4. What does that add up to? Negative 1. Okay, that's what I want. Negative 5, positive 4. Okay? Okay. Let's do some patterns. We already talked about one pattern where I said if it's plus, plus, plus everywhere, then everything is a plus, plus, plus. That's the easiest thing. Okay? So look at this one. All right? If you have plus, plus, it's the easiest one. Plus, 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 plus. Another very easy one and a good one to remember is, but you can't mix up this order, right? If you have minus plus, minus first, then plus, it's minus minus. That's a good one to remember as well. Okay? But it has to be minus plus. Now, and then any other combination, if this one is a negative, no matter what you have here, it switches. Does that make sense? So the only ones you know for sure is if it's all plus, and if it's all, like if it's minus plus, then it's minus minus. Okay. So this one, look at this one. So this one is minus plus. I'm going to have xx. Since it's minus plus, I know it's going to be minus minus here. Okay? Now, I need two numbers to multiply to 4 and add to 5. What do you think? 4 and 1. X minus 4, x minus 1. And if you get confused, FOIL. Okay? All right. So these are all mixed type of problems. So for each one, we want to be careful to see if we can factor out a GCF. So look at this one. X squared 3x 40. Is there a GCF we can factor out? No. Because x squared 3x and 40, there isn't a GCF. There isn't a common number that we can divide all of these by. So let's see what we're going to get. Now this one is minus minus, so I don't know here. The signs can go either way. So let's see. So I put negative 40 here, right? That's what I want them to multiply to. And then what do we want them to add to? -3. Okay, so let's see. So what are we gonna get? 40 and 1, that's never gonna work. Yeah. Oh, look at you. -8 plus 5. Yeah, that does give you -3. So that's the one. -8 plus 5. Okay. Okay. This one, is there a GCF we can factor out?
Yes.
What can we factor out? A 2. 2 is the greatest common factor. So this is going to be x squared minus 7x minus 44. Okay. So now let's see. I need -44 as a product. Oh, what multiplies to 44? Yeah, Ayal? So B, I wanted two numbers that multiply to -40, but they add to -3. So Eliana said -8 and 5 is -3. Yeah. So this one I want -44. Oh, oh, look at you guys. So -11 and +4. Good. So now look, remember this 2? Don't get rid of that 2. Bring it along. X minus 11, x plus 4. If you remove that 2, it's wrong. Okay. No, don't distribute because then you get back to where we were. So this one, xx, look, I have minus plus, which means this is going to be minus minus. So now I need two numbers that multiply to 42 and add to 24. What are the factors of 42? 1 and 42. So they have to be like pretty big. So they have to be a pretty big difference, right? Is 2 and what else? 2 and 24. Okay. There are no numbers that add to 24, right? That multiply to 42. So then what? You can't factor it. We call it prime. Okay? We call it prime. Okay, let's do this one. No solution doesn't work. Say prime. Because it does have a solution. It just can't be factored. So we say prime. Okay? Okay. Later on in Algebra 2, you'll learn that there is a possible solution, but it's not factorable, so we can't. So it's prime. Just like for example, 8, right? It has factors, right? 2 and 4, 1 and 2. I'm sorry, 1 and 8, right? But 17 is prime, right? Because it doesn't have any other factors. You can't break it down into any other factors. It's prime. It's a prime number. So is this one. It's a prime expression. It's the same idea. You can't come up with any factors to it. Okay? All right. Let's do this one. So this one is xx. When you have minus minus, 1 is going to be a plus, 1 is going to be a minus. So what do you guys think? Can we come up with numbers? -9 plus 2. So again, another way like to do it is, people put the -63 up there, the -2 here, and now you're like, okay, I need numbers -9 and 7. Right? You need numbers that multiply to the top but add to the bottom. -9 and 7. Yeah. Okay, here, is there a GCF to factor out? Yeah. What? X. I can take out an x, so I get x squared plus 9x plus 8. Okay, go ahead and factor that one. Right? Okay. All right, go ahead and do the bottom two. I'll race you to it. Are you guys ready?
Yeah.
Any marks? Get set. Go. Okay, I'm done.